Yeah, I think it is starting.
Yeah, I think we can start.
Okay, so good evening and good morning. Greetings wherever you are from Mechanical Engineering Indian Institute of Science, and welcome to this distinguished seminar series, which is being conducted as part of the 75th year celebrations of the department. Today's speaker, I have great pleasure in welcoming Dr. Murali S. Nair from the National Science Foundation, where he is a program director of their SBIR STTR program. Dr. Nair is a graduate from IIT Madras, and then I believe after a short stint here in IISc, he went on to the US and got picked up his degree from the University of Texas. And then he, I guess, was a faculty member at the Embry-Riddle Aeronautical University for a while before he went into industry, starting with Motorola, where he was part of the Iridium project, which was this very large project that Motorola had initiated for a constellation of satellites to provide communication from the skies. And then he went to Hughes, which is another satellite communications company. And after which, I think he forayed into the entrepreneurship journey. He founded a wireless product company. And I guess he was able to successfully raise funding for this and create and make it into a sustainable enterprise. And I think then he decided to sort of go the other side and join programs that will create more such companies and ventures. And so he joined NSF in 2003, and his areas of responsibility were the emerging areas then: robotics, Internet of Things, wireless, and space systems. He is the founder of the Division of Industrial Innovation and Partnerships at NSF, and he was awarded the Meritorious Service Award of NSF for this particular achievement. Presently, as I said, he is a program director in both the Small Business Innovation Research SBIR or Small Business Technology Transfer Program. This is a program that many countries have since tried to replicate, including ours. And so it will be interesting to hear him speak about his experiences in running this program. As we were discussing just before the thing started, he's also published a couple of books on this area. One is already there, and I really like this title, New Industry Creation, and the sub title there to that is Discovery to Innovation and Technology Startup Narratives. But the new industry creation is the part I like because it implies a sustainable, industry is. And he is working on another book right now, which should be out in another 2 years. But more interestingly, he also writes fiction. And he has one already out, which is titled We Are All Little Gods and Ordinary Life. And apparently he is in the process of creating another one, which should be published in a year's time. So with that, let me again thank Dr. Nair for agreeing to give this talk and welcome him to give his presentation on technology startup funding by the US National Science Foundation. Dr. Nair.
All right. Thank you, Guru, for that very kind introduction. And welcome to all of you for taking the time to listen to some of these slides that I have prepared for you. Mostly it's about startup companies, the high-tech or technology startup companies. So I'm going to very quickly go through some of these slides, and I hope Ratnesh would help me do that with the next slide. And I'll just say next slide when I'm done, Ratnesh. Okay, so we we will try and cover a few ideas about at least the origins of NSF and the specific program, the SBI program at NSF. And you'll see that we have lots of special things and special ways of going about this program or implementing this program, and talk a little bit about that and what it is that we're looking for in terms of startup companies that we can fund and we don't fund. So just so you know both sides of the fence about funding. And then I'll spend a little bit time. Maybe it's kind of useful, could be useful to you, especially those of you who are involved in trying to do creative, like like Guru said, new industries. So that's what the talk is about. And I'm trying to finish it in about 45 minutes. Keep enough time for questions from you. Next slide, please. Yeah, just keep going. Yeah, so this is about just to give you a sense of the size of the National Science Foundation. It's a federal agency, but a relatively small agency because there are other agencies that are like almost 100 times the size of NSF. Example, the Department of Defense. Is about 100 times the budget. Anyway, this current budget is about 8.5 billion. Jayant suggested that I put some numbers in rupees, and so that's what you see. It's about 63,000 crores rupees. Next. Very quickly, I won't spend time on many of these slides. Just to give you the structure of NSF, there are 7 directorates at NSF, and we operate out of the engineering directorate, one of 7 directorates. And you can see that it goes from research funding from biological sciences all the way to education and human resources. So 7 directorates at NSF currently. Next, please. Drilling down a little bit on our division, which is the Industrial Innovation and Partnerships. It is part of the Engineering Directorate. There are 5 divisions, and this is kind of unique. IIP, Industrial Innovation and Partnerships, is unique division in all of NSF. But even among the engineering, in the engineering directorate, the other 4 you can see they're all very research oriented and fund areas of engineering in all areas of engineering. So the next slide would tell you a little bit more about our division. Next, yeah. So just a couple of minutes on this particular slide, just so you get an idea of how it is structured within NSF, the program. Now this is the SBR STTR program for the most part. So you can see that we cover all kinds of technologies. In fact, it doesn't matter what the technology is, as long as there is a technical risk to be taken care of, and there is a potential market. So those are the really only top level conditions for what areas of technology we fund. We normally, I show this here on this slide, the boxes here in sort of light blue, just to give you a feel for the various areas of technology we normally fund, but we don't restrict it to these areas. But these generally practically cover all areas of technology. So that's the SBR STTR part of it. And then this may be kind of important or useful to you that within the division we have this academic cluster too within our division. So these, just to emphasize that the SBR STTR program, all the funds allocated to this program is must go from NSF to the small company directly, right? There are no in-between players. So all the money in the SBR STTR program must go from us, from NSF, to the small company directly, right? And whereas the academic cluster, you can see that we have essentially 4 programs plus an intern. That's really a supplement, it's not a real program yet. But all that money, that's about right now about $80 million. That goes from us to the university. So that's the difference between why we call it the academic cluster, because all these programs are kind of priming the pump for SBR STTR. So you can see, for example, the Innovation Core is a program that helps faculty and mostly graduate students, but it could be any student, to kind of go to the market, understand the market, see what the potential solutions that are lacking or the solutions that may be required and so on. So there's a program usually lasts about 7 weeks, and it's essentially to make faculty and graduate students go into the market and find out. They have to interview or talk to, I think currently it's about 100 companies. You have to do that for the money we give them. So that's an example of money flowing into the university, but for purposes of innovation and creating startups. All of these programs have something to do with startups. Another one is partnerships for innovation. That's quite large in the sense that those are about, it can go from $500,000 to a little bit more dollars for, again, faculty. This is mostly, again, faculty and students, to try and see if the research that they're doing might have potential for some applications or products or services in the market. So again, these in blue are academic cluster programs, a total of about 70 to $80 million a year, and they're all targeting faculty and graduate students for the most part. Okay, next slide, please. Yeah, so just want to let you know that this slide deck has about 12 examples. The first 4 are going to be shown in the next next 3 slides and this one. These are examples of companies that we have recently funded. These are all NSF, SBR, STTR companies. So if you go to the link, it says NSF and a number. If you click on that link, you can get the abstract of what these guys, this company, and this one happens to be in synthetic biology. So the abstract obviously will tell you a little bit more about the technical side of it, the research side of it. So if you click that, it'll take you to the abstract, to the NSF website and to the abstract. The second link, it says article via Biospace. I'm not going to click it here, but if you do, then it'll take you to an article or some write-up in the popular press. So it'll be more like something that people can understand easily, not too research oriented. So that's what these links are. If you go to the next slide, please. Yeah, now you see that there are 3 links. The previous one had only two links. One is to the abstract, and the other was to an article in a magazine or a publication. Here you see three links. So if you click the first, it says Biomason. It'll take you to the company website, Biomason's website. So you can learn more about what they do. This is basically trying to substitute for traditional cement with microbes, biocement. So if you click Biomason, it'll take you to the startup company's website. The second, again, the same, it'll take you to the abstract in the NSF database. And then the third, in this case, an article in Forbes magazine. I'll tell you a little bit about the societal or the commercial viability and aspects of this particular product or this particular company. So I won't spend too much time, but this to let you know that all these links, I'll spend time on one of them because it's relevant to India, but the others I'm just going to flip through. So Ratnesh, could you please go to the next slide? Another example, this is for infection and blood infections. Next slide, please. And this is a robotics company that was given some award from the World Economic Forum. And again, you see three links, and you can, if you want to know more, just click on these links and they'll take you there. All right, next slide. So those are, I gave you four examples. There are a set of another four, two sets of another four each. And on one of them, I'm going to just show a little video so that you get a feel, and it is pertinent to India. And that's why I'll spend a couple of minutes on it. All right, so now we're going to talk about NSF's program, NSF SBR STTR program. Next slide, please. All right, so the budget right now, approximately this last financial year was about 1,600 crore rupees. And you can see what the program is about. Is basically we're looking for technical risk, something that we don't know the answers to technically. So that has to be part of the proposal. And the other, of course, is some understanding of the market or where's the potential for success in the marketplace, right? So uh, in a normal year, we might fund between 350 to 400 startups. That's been you can say that's the average over at least the last maybe 20 years, almost 20 years that I've been associated with this program. So 300 to 400, 350 to 400 startups every year. So these are phase ones, and we'll talk about phase one, phase two a little bit later on. Next slide, please. All right, so I think some of you may be familiar with what this slide is conveying. It is this area of development, right? That's always actually kills startup companies. That's why they call it the valley of death. It's where startups go to die, right? So we want to rescue them, uh, not let them die. If they have potential, if we see that these technologies have potential, we don't want them to flounder in this development area of this graph. So that's where the SBR funding comes in, starting with the phase one, phase two, and then many supplements that we give these companies because we've already invested more than $1 million. By the time they get a phase two, we've already invested $1.25 million into the company. We try and not allow them to fail with these supplements. So these supplements themselves can lead up to or could add up to almost $1 million, additional $1 million. So that's very helpful to the companies. Not all companies will get that because they have to show that they're really approaching the market in some way and they have pretty good understanding of how to do it. So we help with a little additional money. Okay, the next slide, please. All right, this I think captures the entire NSF. This is NSF SBR STTR model. I don't know if you know that this program, the SBR STTR program, is among 11 federal agencies. So keep in mind that the SBR STTR program started at NSF in 1978, 79 is when they ran the pilot. And then 1980, which is more than 40 years ago, actually became law. And it was signed by Reagan, the president at that time. So we've been, at least NSF has been doing this for more than four decades. So what this does is it's a phased approach, and we start by funding a company about $250,000 and between 6 and 12 months. So to see if these guys can alleviate the technical risk. Mostly phase one is to kind of wash out the technical risk if possible. Many, of course, fail, but many succeed too. The percentage, just to give you an idea of phase one funding, historically has been about, I would say, 8 to 10%. So for every 100 phase one proposals that come in, 8 or 10, maybe 12, somewhere around that, depending on the circumstance, will get funded with a phase one. So it's very competitive. So 100 companies, let's say 10 companies get funded phase one. But the good part of it is that once you have a phase one from NSF, then the chances of getting phase two are quite high, relatively high. It's like, um, I would say between 30 to 50%, meaning 1 in 2 or 1 in 3 phase ones historically will get a phase two. So that's the statistics from at least 20, if not 30 years. So very competitive at phase one, but it eases off a little bit because they've already got a phase one, and then that's the door that is most difficult to get through. So once you get phase one, phase two chances are pretty good, and the money is also quite large. It's 1 million, so that can sustain a small company. Usually these companies, I'll come to that later, the size of the company, but I mean, they're on their way if they have a phase one for the most part. The chances are pretty good that they'll get a phase two. So together, that's about a 1.25 million. The numbers in brackets are in crores of rupees. Um, just so you know, in terms of rupees, what the size of these awards are. So during the phase two, which is usually 22 years, sometimes they finish or they want to finish quicker, especially in the software area. They can, if they want, finish in 1 year. But in other areas, the hardware side or the biotech or manufacturing kinds of things, it takes more time. So 1 to 2 years, mostly 2 years. So during this time, they're allowed to look for supplements. So that's what this the circle above, it says phase 2B. We're just highlighting this particular supplement because it's the largest. So, but you don't get that unless you bring money to the table. So the small company must bring, equity capital or sales or revenues of some kind, or some source of income, which will match. But if there is no such source, then we won't match it. So to match the phase two, uh, or give a phase 2B supplement, you must bring to the table something to show for your work in phase two, meaning somebody in the market or some company or a partner or a customer is willing to put some money, or a private equity, venture capital. Mostly it is venture capital. If they're willing to put money into the company, then we will match that. So normally, I don't know, a lot of companies these days, it was not so many years ago. Like I was telling Guru earlier, that all this takes a lot of time, and you got to build this reputation and so on for these private entities to come in. So before, like say 20 years ago, I might have seen, when I first joined the program, I might have seen, let me give you a good number here, about let's say 100, maybe 150 million coming from private sources for the entire program, right? At that time. But now, I would say it's more like uh, maybe a billion or more on average. Because people have begun to know the program. They know what kind of technologies are being developed, and they know the reputation of this NSF program. So there are many things that go into the mix. So they're confident. These private investors, they're confident that when they see a phase two company from NSF, they pay attention, take a serious look, and they're willing to put money on the table. So these days, in my portfolio anyway, in robotics, wireless, IoT, and space, there are companies that bring in a few tens of millions of dollars during phase two. So it's a program with a reputation nowadays. We'll see how long that lasts. Okay, I hope that tells you a little bit about program uh, overall, a little bit about the program. Okay, next slide, please. All right, next, keep going. Okay, these next, I think, 4 slides are essentially telling you what's so unique about this NSF's program. Most of the size of the company, these are very small companies. Most of them are 1 or 2 people companies. Most of them. Like it says 90% have 10 or fewer, but it's more like 2 or 3 of something like that on average. Sometimes we have just one person, right? So 90% of the companies are real tiny startup companies, between 1 to 3 people. And they've never had any funding from, we don't kind of encourage that you've been getting funding from other agencies or from NSF before, and you're coming back again. We don't encourage that. These are, for the most part, coming or getting funding from NSF for the first time, or from any agency for that matter. We really want the startup companies truly called startup for a reason, that they're just starting out and they've not got funding from any other source. And NSF is going to put the first money into the company. And so obviously, if they succeed, we take the credit, right? We don't have to share the credit. I mean, not that it's a policy thing, but that's how it happens in reality. And then they haven't been around for too long. They're really true startup companies. It says within the past 5 years, but in my experience, They might have just incorporated for the most part. Here and there, you'll find 2 or 3 year old company coming to us. But generally, they are true startup companies. Okay, next, please. All right, I'm not going to read through all this. Some of these slides are just for completeness, and you have the slide deck. You can take a look. Let me see if there's anything here that. Oh yeah, see this. A couple of things. One is that NSF is not a customer. We are not buying anything from any of these companies. The reason I bring that up is that other federal agencies, they buy products or services or process or whatever from the companies they fund, like because they have a need. They're like a mission agencies, they call them, like say Department of Energy, for example. So they have things they're looking for, in say batteries or in some solar thermal or some whatever, right? And they actually would grant them a contract. See, all NSF money is grants, all of it, 100% grants. But there's the other extreme is like, say, Department of Defense, for the most part, Department of Energy and so on. They're all contracts. So what does that mean? Contracts meaning, hey, I'll give you this money, you do something for me, right? You have to do something for me and I'll pay you for it. So they're all contracts, whereas NSF is unique that they're all grants, 100%, all grants. So we don't need anything from the customer. We don't care to buy anything from them and so on. The other is that we are focused on going to the market. Other agencies may not be because they may not require it because they're looking for their own needs. Depending on their mission. Say, hey, can you do this for me? I'll give you a contract and you give me the product or service back to me because I need it. But NSF doesn't. So that's a very fundamental difference between what we do in this SBR program, different from the other 10. So there are 11 agencies that have SBR STTR program. All right, next slide, please. Yeah, here, it doesn't matter what area, really, what area you want to find solutions in. It really doesn't matter to us. So that's why it's the broadest program in all of the 11 programs. So it doesn't matter that you have to do some research and take it to market in a particular area of technology. And we tell them upfront that this money that we give you, the phase 1, phase 2 plus supplements, is not going to be enough for you to succeed in the market. So you have to raise money or find customers or find partners to keep going. Because after the first phase 1, phase 2, and supplements, we sell them very rarely, unless there's some kind of pressing social need. We rarely give them another phase 1. I mean, another cycle, phase 1, phase 2, and so on. Okay, next slide, please. Yeah, this is just information slide. You can see all the technologies that we support. Yeah, next slide. Again, for completeness, but I'm not going to talk through it. Yeah, so this is another set of 4 examples. For lack of time, I'm not going to get into these. But again, remind you that the first link to the name of the company takes you to its website. The second link with the NSF number is the awards database, gives you the abstract, the technical abstract. And then the third is an article that's out in the public popular press. So you can go through the next 3 slides. Go ahead, Ratnesh. And stop at Promethean, please. Yeah, next one. Okay, this one I just want to kind of, no, the previous one, previous slide. Yeah, this one is relevant to the one I mentioned that is relevant to India, right? I don't know if you can, oh, I can't do the link here. I thought I could go to the link. Anyway, I'll just talk through it. So Promethean, like it says, oh, let's see. Should be this one. Can I get this link? Article? No? Okay. All right, that's okay. Oh, it did go there. All right. Yeah, I just want you to get a feel for some of these things that we're trying to do here. If you go down, yeah, go, Ratnesh, please go down to a YouTube video, some more, some more. You can see, stop there, Ratnesh, 1 minute. Just go up a little bit, go up a little bit. One more. Yeah, you can see that, yeah, no, the impact, our impact. Okay, here, stop there. Go up. You know the numbers, it says yeah, they're right there, right there, right there. So you see that they have mostly in Tamil Nadu, they have already installed, not all of it, but all of Gujarat and other places in India. So this is a company funded by NSF, SBR, STTR program. They've already installed about 1,200 of these. 60,000 farmers have been served. 700 million liters of milk chilled, and 3 million liters of diesel saved. So what they found out was this. Okay, now go down. Let me see if we can go to that YouTube. Yeah, some more. Yeah, one more. One more. No, not this one. The next one. No, next one. The Promethean power. Yeah. Play that. Let's just see. We just played for a cover. It's 5 minutes, but I'm not going to go on for 5 minutes. Just a minute or so, just to give you an idea. Is there a sound? No? Yeah, anyway, in
Yeah.
your own time, please take a look at this one because it has had a serious impact on the dairy farms in Tamil Nadu. For the most part, they started there. And they've had some serious, I mean, they've provided serious benefit to lots of dairy farmers in Tamil Nadu. And this is all, get rid of diesel generators and do this using some kind of thermal batteries. It's a good story, so you might want to check that out. Okay, that's enough, Rajneesh, because you guys, on your own time, please take a look. In fact, please take a look at some of these examples that I provided, 12 examples. They will tell you quite a bit about and these are for kind of recent, so it doesn't mean that the companies are recent. See, if you look at the number, NSF 12, 5, 6 something, right? The 12 says it's the year. It's, uh, what is it? Let's see, 2012. So this company was funded by NSF in 2012. And so, in about 7 years after that, is when they started setting up these milk chillers all over Tamil Nadu. So, so these numbers tell you a story also a little bit that this was funded in 2012. Okay, just go to the next one, please. Okay. No, just go up. Sorry, Ratnesh. Just go up one, couple more. Yeah, see now this is 16, right? Oh, this is 13. So it's funded in 2013, and the other one was 2016, and so on. So check it out if you have interest and time. check out these examples that I'm providing here. There are many more examples in the book that I wrote. There are like almost 60 examples, most of it from NSF SBIR, but some of them from other agency SBIR are also featured there. Okay, let's go down. Yeah, next slide. Okay. So this slide and the next one tells you what is it that we're looking for and what is it that we don't want to fund, right? So what we're looking, these are kind of essential to the program. It has to be kind of new. It has to be that it hasn't been done anywhere in the world, okay? Anywhere in the world, not just in America. Anywhere in the world, is, as far as we know. I mean, some keep it very close, that they don't tell you about it. But as far as we know, it's not being done anywhere else in the world. So it's got to be novel, and there must be technical risk. I mean, without that, we're not interested. I mean, you've got to have technical risk that somehow the research is such that it's too early, or there are many unanswered questions about the technology or the science itself. And then, of course, there's got to be some end point. You know, it's not research for research sake, which is all fine and good. But here in this program, it's got to lead to something. All right, then next slide. So this is what we fund and what we don't. Basic research. That's the rest of NSF. So that's what NSF does. But we don't do that in this program. And then any incremental things, we're just not interested in that. Uh, let's see, just reading through it. Oh, one other thing is that if NSF funding cannot move the needle, right? Meaning it is not impactful, then we don't want to fund it. So NSF funding, that's why they're very small companies, right? One or two people, because they haven't got a chance to move forward yet. So this money, this $250,000, and then then $1 million, will make a difference to this company, right? Because they're so small and they're just starting out. This is a lot of money, and so it will. We hope, and it does. In most of the cases, make a big impact. So we want to see that. We want to, just like that milk example that I just gave you in India, right? Is using technology out of MIT. I think it was, I don't know, 10 years ago maybe. Some materials technology from the MIT, and these guys, at least one of them, say he's a technical guy. He kind of hooked up with a business guy, and these two were the founders. And they just they did actually, they went to India for some other purpose, thinking they had a solution to some unknown problem, right? That's what that's how many MIT type projects turn out to be. That they have a solution looking for a problem, right? So that's how it started, and then they just bumped into Bangalore Dairy or some milk producing entity in Bangalore, and they just by chance, this guy, he called him cold call this managing director of I think it's Bangalore Dairy, and I said, he says, come on over, we got a problem, let's talk. And then he told them the problem. What the problem was that this milk was getting spoiled. There was no way to kind of cool it or keep it chill till they took it to the market. And then electricity supply is uneven, and they have to use diesel, which is very highly polluting. So this problem he shared with them, and these guys thought about it and said, "Oh, okay," and they changed their whole research plan and the product development and everything around that problem. So They saw a problem and then came up with a solution which wasn't the original solution at all, right? So that's a good example. By the way, Guru mentioned these technology narratives that I wrote, about 22 of them. One of them is this company. So that those 22 case studies is what I call them. I just compile them into a book. Of course, I had to write it and interview these guys and talk to them and get some insights. And so you'll see other examples there of an example like this one, this Promethean is one of the 22. All right. So, yeah, next slide, please. Yeah, discovery to, okay, next slide. Yeah. So the question is, what does it take, for a proposal? Some paper proposal comes in. We get about, by the way, about 2,000 to 2,500 proposals a year, phase one proposals. So this phase one proposal comes in, one of, say, 2,000. So how does that proposal become a successful company? That's the question. So that's what the next few slides talk about. Uh, let's let's go to the next slide. I think I'm taking too much time. Let's go to the next slide. Okay, these are some returns of NSF investment. And you see they're pretty sizable. Last 5 years, the companies we have funded have raised what is it, 66,600 crores in the last 5 years. And even in the pandemic, we were curious to know, so we checked it out. It came down, but not bad. And then very high tech, many high tech jobs, almost 100,000 in the last 5 years. These are high paying jobs, right? 100,000 annual salary, 150, whatever, some high number. Okay, let's go, Ratnesh, next one. Okay, so this is like I mean, maybe you can take a look and think about it, but we're trying to answer the question: how does a proposal that comes into us and we fund become a successful company, right? That's the question. So, from my experience and from my understanding, or whatever little there is, this understanding of all this, is that these 10 essential items are required. These we have seen from experience of many decades, and personally, a couple of decades almost, that these have to be there. Otherwise, it's very difficult. It's very difficult to make it happen. One very key, that is quite common here in America, maybe not in any other country. Okay, even Europe, this, that, Israel, maybe, but it's so small. This business of early adopters. These guys are willing to take a chance. Some company, like SMEs that Guru and I were talking about, they're willing to they say, okay, let's adopt, let's get your product here. We'll try it out. We'll try it out in the market. We'll refurbish it and then make it a real product, and let's see. We'll try it. So these are the early adopters. If you don't have that, no one is willing to take the risk with this new service or product, then it's kind of difficult. So that's the kind of key. That one, and the rest of it, is all pretty standard stuff. But this support networks and technology specific networks. It depends, you got to have networks of people, investors, business types, companies, industry, all surrounding a particular piece of technology. That helps a lot. you know. For example, I don't know much about this, but in Pune, for example, in India, there's a cluster of automotive parts manufacturers, right? Or in Bangalore, the IT that everybody in the world knows about, right? Or even I give you some other examples now. So anyway, this ecosystem has to be there. Uh, each of them. It's not like, okay, we can do without one or two. No, no. It has to be all to make it work, to make it success. Okay. And I've mentioned my book here. Usually I try not to plug my book and this and that, but I think I'll lay the blame on Jayant. He, he said that I should talk a little bit about my book. So okay, here it is. The next slide. So that's one fundamental thing, right? And then you have to create some kind of demand somehow. You got to talk to people. I don't know how you do it. Okay, these are all very difficult to do. It's not easy, and it takes a lot of time and effort to do all this. It's not overnight and so on. It has to be like a dedicated set of people, right, for years, just focused on this, just like we have been. For example, me, I've been doing this, like I told you many times today, for 2 decades. And so you learn, and each of us learns, right? Learns what works, what doesn't work, what should we do, what should we try. So out of all that is what this facilitate two things: facilitate market entry, help them, and then come up with some strategies how to get to the market. And then I mentioned this couple of times already today. This regional technology clusters. You got to work around those if there are, and in India there are. Lots of places where there are clusters, like, say Coimbatore, there may be textile clusters there. Or like I mentioned, Pune or Bangalore, or there are other places uh, in India that they have done this for a long time. So you got to leverage those. Okay, next slide, please. Yeah, I want to try to wrap up now. Yeah. See, these are the examples. I mean, you look at India, right? These are India examples. They're doing very well worldwide, global success. IT, pharmaceuticals, healthcare, and many more. I have many examples that I know of, but I only listed a few here. And then, something I call poor technology. That's very different from what's happening in the West. Okay, it seems like technology caters for the well-off and the rich, and those kinds of things. Seems like to me. Anyway, the book that I'm currently writing is going to address these kinds of issues in it. Uh, but what about all the rest of the world, the rest of the planet? So many things missing pieces. With regard to hunger or water, I mean, basic problems not being addressed. So why don't we use technology for those kinds of things? Innovation and technology for these kinds of things. That's my fundamental problem in my mind anyway these days. Is all this is fine and good what we do here, but they're all catering to the well-off, right? They're already well-off. And so, given some examples, I was very impressed by this Narayana hospital system in Bangalore. This is in Bangalore. I mean, there are guys, a surgeon, a heart surgeon here, who's trying to kind of do heart surgery on a mass scale, right? Very cheap. I mean, they cost like 100,000, 200,000 here in the US dollars, and he's doing it for 4 or 5,000. How is that possible? But he does it. He's doing it. So same thing with all these other things that innovations that have come up in India, right? Aadhaar, for example. Imagine everybody has a number. So to track it, to make sure they're not hungry, or whatever the reason, or pratham in education, primary schools. So many such examples. There are dozens of them all over the world, but quite a few in India. So that's another area that needs innovation, and it's already being done. It's not as if we have to teach them. It's already being done in India. Vaccines, for example, biggest vaccine manufacturer in the world, India. Okay, next. I think that's it. Next slide, please. Next slide, yeah. Okay. So this, I think, I don't know if there's one more, but this is what we do. I mean, I was talking in general in the last 2, 3 slides, but what we do to make a success of this program, depending on what the mission is and the vision, we do this to help. So we got all these entities. In fact, I was very much involved in the first one, the Innovation Accelerator. For 5 years, I was running that as part of the program here at NSF. And that, just to give you an idea, we spent about I think, wait a minute, 8 million for 5 years. We spent 8 million in 5 years, and we got returns of about 350 million through that accelerator. So 300, like, I don't know how many times that is, maybe 50, almost 50 times. So there are ways to do this, but it requires a lot of thought and a lot of dedication and kind of passion, focus, all that. And then, a whole bunch of supplement. I talked about the phase 2B, which is the biggest, but there are others. They're all about 150,000, each one of them. And TABA, this is for IP protection and those kinds of things. It's a smaller supplement, 50,000. So together, if you add this all up, it's about 1 million. On top of the phase 2, the million they get in phase 2. Okay, I hope, let's see, what is the next slide? Is it the last one here? Oh yeah, then you got these bunch of 4. Yeah, just click through them, Ratnesh, please. I think got 4 of them. Yeah. Yeah, take a look if you're interested. These are good examples of what we find. I mean, the latest example. They're not latest, because now you see this is 20. You see NSF 2025? So 20, that was funded in 2020. So this is to manage wild horse population. All right, let's see the next. That's it, right? I think, sorry for taking more time than I'm allotted here. But like I said, I'll be around if you have questions for me. That's it. Thank you, everybody, for your patience and for listening. And if you have any questions, please, I can try and answer them if I can.
Thank you, Dr. Nair. That was quite an interesting journey into the whole system of SBIR. As I said, it is a much copied
Yeah.
system, but not perhaps with the same success. So thank you very much for that. We are now open for questions. I guess you can raise your hand or just open your mic and speak. Right track, and if somebody else can also help me spot the people wanting to ask. I see Achitava Ghoshal has raised his hand. So Professor Ghoshal.
Yes, Dr. Nair, thank you very much. I was just curious. So you said you get these 2,000 proposals. So do you have a big team who is evaluating these proposals? So do you take help from?
Yes, we do. I mean, we have, like me, there are right now 10 others. So we have a team of 11 program directors. So all these are in different, they handle different areas of technology, right? And then when these proposals come in, they're sorted into these various areas and handled by a particular program director. And they all have to go through a panel, the review panel. Every proposal that comes in goes through a panel of experts. These experts are made of a mix of highly technical people from universities and in phase 1, maybe a sprinkling of people from industry and from private, like venture capital. in phase one. But in phase two, it's a half and half. In phase two, because it's $1 million, you'll have half the reviewers, experts, technical experts, and the other half are financial experts. Half and
So, so it must be because some of these ideas must be very new, right?
yeah.
So I guess in US there are enough people to evaluate these ideas. That is,
Yeah,
I
there
think,
is. I mean,
that is a difficulty here, I would
yeah,
assume.
that is true. We are lucky here that you have so many universities, right? I mean, like, I don't know how many there are, research universities. And like, just to give you an example, in my areas of robotics, wireless, IoT, and space, there are at least 500 research universities dealing with these technologies, right? So, in practical terms, I have a database, my own database of maybe 300 experts that I can call on for each panel. I don't like to use them more than once in a cycle, but I have enough, right? I have enough numbers so I can tap into. Yeah, so to your point, that there are so many people required, and it may not be available in India right now. But you can. It takes time, right? I was telling Guru, I was telling Suresh that all this takes time. You got to build it, build it, build it slowly, slowly, and you will find that there are enough people in India. There are. I know that,
Uh,
but we
yeah,
just don't know them.
thank you very much. Yeah, I
Yeah.
think because there is a lot of difficulty, practical difficulties like that in India, which
Right,
is
right. Yeah, I
we have to
understand.
overcome.
Yeah,
Yeah,
I
thank
understand.
you.
Yeah.
Guru sir, you are on mute.
Yeah, Guru, I think you're on mute. Okay.
Sorry. Okay.
Yeah.
Anand Suresh. Yeah.
Yeah. Okay. Thank you, Dr. Nair, for explaining everything in great detail. So now I think in India, people are getting through this phase one and phase two with similar funding that you explained also. NSF similar model is followed here. But after that, when it comes to venture capital as angel funding, they really struggle because
Yeah.
it is coming up in India, but it's mostly given for software and not for
Yeah.
hardware. So in 1980s and earlier when it started in NSF in the US for these programs, were there similar difficulties? How long did it take for people to trust these startup companies to actually deliver beyond phase
Yeah.
one, phase two support?
Oh, yeah, yeah. It was difficult. I can only tell you from maybe about 20 years ago, when I first came into the program. It was not that, even then, it was not that easy. Although the program has been going on for 20 years by then, right? When I joined, it
Mhm.
was still quite different. And the other big difference is that when I started, those days, about, I would say, 50 or 60% of the proposals, they were coming from the same companies over and over and over, because they saw this as a kind of well of funding, right? They know how to write proposals. They're very good sounding the proposal, and they keep getting funded over and over and over, right? This was 20 years ago.
Mhm.
We saw that and we started to slowly, slowly change. When now, this is just an example, I don't know if I'm answering your question, partly maybe, is that now we hardly fund any of those. We truly fund only startups. So that took 20 years, right? The other part about your VC concern is that too takes time. I mean, if you look at the 1960s, 70s, 80s in America, there were hardly any guys. They didn't even know about the SBI program. They had no clue. Okay, until the 80s, even the 90s, they have no idea of this SBI program. They didn't care. They didn't want to know. Right.
Mhm.
It was only slowly that it started percolating within the consciousness. Right. That hey, we need to pay attention to this program, because there are some serious companies coming out that are kind of succeeding. So we want to jump into the action. So that took another 10, 15 years. So again, when I say this takes time, it's not easy. It's kind of generational shift almost. It is not going to happen overnight. I mean, we know that the problems, like India, maybe like 15, 20 years in this type of program behind. It may be. So what? But you just have to keep at it, keep at it. Only then you'll see when you look back, say some of you, when you look at the younger faculty, suppose you look back 20 years from now, you say, man, what a difference we've made. But it takes time. We have taken time. Even with all this infrastructure here, it has taken decades, at least 2 decades. Since I first joined, it was a very different program when I joined. Very different program. Nothing was coming out of it. There's no real outcomes. It's just some research funding going on. Another source of research funding. There was R, but no D.
Good to know. Thank you. Yeah.
Thank you. So, Banerjee, Diwakar.
Hi, thanks for a great perspective. I had a sort of two-part question. I assume you must have clearly defined criteria for evaluating the success of a small business award. And if you do have such criteria, what percentage of awards since the program started have actually been successful, given the high risk and the value of the context that you described?
Right, yeah. Yeah, let me see. Let me think a little bit here. Yeah, I would say, see, like I just look at the numbers, right? Let's take just a round number, 2,000 proposals coming in. We're funding about 100, let's see, wait a minute. Maybe 250, like I said, 300, let's say 300 phase ones a year, right? 300. Out of that, 150 on the high side are getting phase two. So 2,000 is gone down to 150 on the high side, right? And out of these 150, real successes. Now you might ask, what is real success? I'll get to that. The real success out of the 150, I would say about 20 or 30.
Okay.
So you went from 2,000 down to, let's say, 30, right? Those are the real successes. Now, what do you mean by real success? Real success means that the company over, let's say, 5 years or so has increased payroll, right? From 3 to 5 to like in the 50s to 100.
Okay.
Right? That they've increased payroll. Revenues have gone from practically nothing to, let's say, 20 or 30 million a year.
Okay.
Yeah. So, but only 30 of the 2,000. These are, we say, highly successful, but there are medium success and all that, right? In between.
Right.
It's not that all 350 are of no good. They somehow survive, but they just limping along, half of them. But 30 or 40, some number like that, they're doing, I mean, they hit it, meaning they become public companies, or they bring in tens of millions of dollars in VC funding, and they create jobs like, 100 jobs. I have an example, a robotics company that I funded 6, 7 years ago, right? 7 years ago, I funded this robotics company. It's in waste recycling, but using robots, waste recycling. These guys, it's already $100 million company. Already $100 million company, already 100 employees. So this is one of those successful that you were asking about. This is an example. There are many such examples, of course, but not that many.
So when someone at NSF evaluates a program like this, they must have some goals for success and a tolerance of failures given the nature of these programs, and clearly that requires a fairly enlightened approach. something that's often missing in our country, actually. So I thought I'd bring it up.
Yeah. Yeah, I mean, see, that also has to do with culture, right? I mean,
Yeah.
India is an ancient civilization. It's not easy to just simply change direction in anything, right? Whereas here, this is a young country. It's barely 300 years old. It makes a big difference to shift and to try this, to try that, and just discard something and move on. All that is possible because society is relatively new and young. So we have to take into consideration all that cultural baggage too, right? How to handle that, or how to find solutions aligned with the cultural norms and conditions. So it's a difficult and takes time and money and a lot of thinking. You got to have some sort of uh, kind of a group, just dedicated to sorting this out, in a way that makes sense in terms of policy or in terms of money, but there isn't much of it in India. That's okay. Many times it's not the money. It's the thinking and the right perspective, and how to go about this in a specific cultural context and civilizational context. Is a difficult problem, but we can keep trying. We just keep on trying. You can find an Indian way. How did this happen with IT? What is so special about India and software? Where did it come from, right? I mean, there are reasons for it. If you study it deeply, there are reasons why India is kind of a leading exporter of IT services. How does that happen, right? If somebody studies that, or maybe people have already done that, I'm not aware. But there is some way of doing these things for a particular society. There has to be. If one needs to do this, I mean, it may not be required. That's the other thing, right? It may not be required. What we do here may not be required in India. I don't know. This is a big question.
Thank you very much.
Yeah.
Thank you, Dipankar. While others are trying to form the questions, let me ask you one, that is to do with the clusters that you had mentioned as one of the key ingredients,
Right.
for success. I was curious as to how these clusters get formed. Are they mostly serendipitous, or they are seeded by probably government or other agencies?
Hmm. Yeah, I think it's a combination. I mean, that's the pat answer, right? It's a combination of many things. But if you look at certain regions of the world, and America, for example, too, like there are, let's say, just for an example, in Italy, for example, there are these clusters of leather works, and there are these clusters of what's the other one that comes to mind? Anyway, there are such clusters in every country, right? Now, for India, or no, the question was, how do these clusters form in America? Is that the
No,
question?
anywhere. Yeah. How did it happen in America or
Anywhere,
anywhere for
right,
them?
right. Yeah, it's like I'll give you an example. In Florida, for example, right? It's a sleepy old place. It used to be 10, 20 years ago. Because I know, because I was teaching in Embry-Riddle Aeronautical University in Florida, right? Central Florida, there was nothing going on in terms of technology. Nothing. 20 years ago, 20, 25 years ago. Nothing. It's just a tourist place, and Orlando and Disney World and this and that, right? That's all. Uh, Now, because of one single university, University of Central Florida, right? At that time, it was like 4 or 5,000 enrollment, 4 or 5,000 students. That is a small university in US, considered small. Somehow, for some reason, NSF started an electro-optics center. It's an engineering research center in the university there. That was the seed. Once this center was set up with about funding like 5 to 10 million a year for 5 years, right? Just to give you some numbers. Now that kind of it would served as a magnet immediately, from all over the country. Guys in electro-optics, anything to do with electro-optics wanted to be there, right? Pretty soon, not pretty soon, 5, 10, 15, 20 years, right? Now it's a center for electro-optics. And all the companies around in Orlando, they're feeding off this university and the expertise in this university. So this is an example of a recent cluster when there was nothing there, right? So this is just one example of many in America, I mean, many. I'll give you another example in Colorado, because I used to, not anymore, I used to travel all over as part of the program, right? So Colorado, I went there like, I don't know, maybe 10 years ago. I went there a couple of times. Nothing much going on. Okay, guys, there are mountains there, all the skiing and mountain climbing and this and that. Okay, that's it. A lot of Subarus, because Subarus are four-wheel drive. It's very good for mountain driving. Okay, that's about it. So I went first once, and this is not because of me or anything, just an example. I talked to some few guys at the University of Colorado, Colorado School of Mines. There are 2, 3 universities around there. Bunch of guys came and I talked about the SBI program and I said this, that. We used to get about 1 or 2 proposals from that whole Denver Boulder area. 1 or 2 proposals a year, right? Just because some of us went there a couple of times and some others went there, it just simply seeded. The thinking, just seeded, right? It's not a big innovative center of innovation or anything right now. It is getting there. But in the 10 years, I have seen now 30, 40, 50 proposals coming from just that Boulder, Denver area, right? Because some of us went and spent time in person, talked about it, held somebody's hand or something, just personal touch makes a difference. So that's another example. So we got plenty of examples that these about clusters. I mean, clusters.
One quick follow-up on that, if nobody has still raised their hand, so I will take my chance. In these grants that you give, either first phase or second phase, do you expect the companies to lock in some contribution of theirs, or you just give the grant no matter what they bring in?
Yeah, they don't need to. There's not a requirement that they put any money or anything. Just work and labor and sweat. Yeah.
Okay, I see a question from Srinivas, Dr. Srinivas. Yes. Yes, Srinivas, go ahead. You are muted.
Thank you very much. What I was asking for is our incubator is also providing services and innovative services to make sure that the medtech quality control is maintained on par with the international. Is there a way that the incubator itself can submit a proposal?
Oh, here to the SBI program? The
Yes,
incubator,
like,
wherever they are, let's say an American incubator in America submit a proposal to our program. Is that the question?
Yes, yes.
Okay. No. It has to be a startup company, a private company, not a conglomeration, not a group entity, nothing like that. It has to be a single standalone company.
Oh, thank you.
Yeah. Why did you ask that?
Because I had under Professor Gurmurthy, I had the technology business incubator focused on medtech.
Yeah.
And along with just incubation, we also have testing services and quality control services, which we offer as a business proposal also.
Yeah.
For our sustainability.
Right.
And as part of that, we have to sometimes, support and also do research into how whether this proposal works or doesn't work in terms of pre-incubation and incubation.
Yeah.
So as we need more devices and systems for better services to be provided.
I see.
And they're all paid services. We collect service fee for
Yeah,
that.
fees. Yeah. Yeah, yeah. Oh, yeah,
Yeah.
that is the model usually for incubators. My question to you is that you can spin out companies from the incubator, right? You can, I mean, because of,
Correct.
let's say, medtech, and you figure out somebody in the incubator or somebody at IISC figures out in medical technology something that's innovative and potentially has a market. And you bring that company or that person to work with the incubator, and then he or she spins out a company supported by this incubator.
No, I think his problem, Dr. Nair, is that he has to show sustainability even
Yeah.
before some of his companies can start spinning out.
Yeah,
That is
yeah,
his
right, right. That
because
is
time that
that's
you
always
mentioned.
the
There is a
chicken
mismatch.
and
Yeah,
egg
there is a
problem.
mismatch
Yeah,
between him. Yes.
right, right, right. Okay, okay. I
Yeah.
understand better now. Yeah, okay. Because I brought that example up because there are a lot of incubators here in America, private mostly, or some state run, state government run, that spin out entities and they apply for NSF, SBR, STTR uh, funding. Yeah.
Okay, I think
Thank you.
it was a warning. Thanks, Srinivas. Timing warning flashed to me, so I suppose we should bring this to a close, the discussion. I
Okay.
would like to thank you again, Dr. Nair, for not only a good presentation, but also your patient answers and insightful answers to all the questions. Thank you very much.
Oh,
And I would,
thank you. Thank you
and I
for
would like to
inviting
hand
me.
it
And like
over.
I mentioned,
Yeah,
sorry to jump
go
in.
ahead.
Sorry.
Sure, go ahead.
Were you going to say something?
No, no, I was just going to thank, so you can
Oh,
finish your
okay.
thing and then
All
I
right.
will
I
thank.
thought you
Yes.
were going to
Yeah.
add something. No, thank you. Thank you for giving me this opportunity. And like I mentioned to you before the start, any which way that I can help, in your thinking or moving forward, if you believe that I can help, please feel free to reach out, and I'll try. I can, bring or point you to resources or people, or in India, for example, things like that. In some way, whatever way, I can
I
help.
intend to do that. So
Yeah.
thank you very much, and I would also like to thank Ratnesh and the department for giving me this opportunity. Thank you very much, and I'll hand it over back to Ratnesh.
Okay. I think
Yeah. Yeah.
Suresh, you wanted to say something, I thought.
Yeah. Yeah.
No, 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 I just wanted to thank you as well. Thanks for
Oh,
taking the
okay.
time
All
and
right.
offering to help us. That is very much needed. Yeah, thank you.
Yeah, no problem.